Zeno of Elea was a Greek philosopher who used a style of thinking called reduce to the absurd to come up with some paradoxes, and for time's sake, I can only look at 4 of them, so let's get into these. Well, he has a set of paradoxes called the paradoxes of motion, and in these paradoxes, he states that motion is impossible or an illusion. In the dichotomy paradox, Zeno asserts that motion is impossible. He uses the scenario of a runner running a race to demonstrate this. He states that in order for the runner to finish running the race, the runner must first run half of the race, okay? Then he must run half of the remaining distance, or 1/4 of the race. Then he must run 1/8, 1/16, 1/32, 1/64, and so on and so forth. Zeno asserts that since you can infinitely subdivide this 1 mile into half lengths, the runner will never stop running the race, since if you add all these distances up, it should give you an infinite sum, right? An infinite series should give you an infinite sum, only makes sense. Of course, this is wrong, and let's get into why in a little bit, but the Achilles paradox is something very similar. In this paradox, Achilles is racing against a tortoise, and the tortoise gets a 100-meter head start. When the race begins, Achilles catches up to where the tortoise is. Achilles goes to A1, but by that point, the tortoise has already moved ahead to T2. When Achilles gets to A2, the tortoise is already at T3, and so on and so on. Zeno says that Achilles can never overtake the tortoise, because whenever he gets to AN, the tortoise is at TN plus 1, meaning Achilles can never overtake the tortoise. He then uses the same infinite series logic to conclude that since the distance between Achilles and the tortoise keeps growing, that it's infinite, meaning Achilles can never overtake the tortoise. Of course, this is also wrong. Let's find out why. We now know that Zeno is incorrect when he says that an infinite series must have an infinite sum. If your common ratio in a geometric infinite series is less than 1, that means that in infinity, your sum will converge on a single number. In this case, it's 1. So when Zeno says that Achilles can never overtake the tortoise and the runner can never finish running the race due to these infinite series of subdivision distances, he is incorrect. Let's talk about the arrow paradox. In this paradox, Zeno states that if you fire an arrow and find one durationless moment of time, then the arrow has no motion. After all, no time has elapsed to allow it to move. Zeno then states that since time is made up of millions of moments, no motion ever occurs, as no motion ever occurs in a moment. This, of course, is no longer correct, as objects have something as we call instantaneous speed. If an object is in a different position than the instant before and after it, then it technically is in motion, even though there's no physical movement in that instant. Zeno has another famous set of paradoxes called the paradox of plurality. In these, he argues that many things and groups of objects, or pluralities, cannot exist. In the denseness paradox, he tells you to assume that there are many things. He then tells you to assume that there are a finite amount of those things. He says if we have object A and object B, there must be an object C in between them. After all, if they are different objects, there must be an object in between them to separate them, or else they would be one object. He then says there must be an object between object A and object C, or else they would be one object, and so on and so on. This creates an infinite amount of objects between objects in order to keep them separate. Zeno then says that since there are an infinite number of objects, this breaks the parameters we set earlier. Nowadays, we would just say that two objects can be different just by having different properties. They don't have to be separated by another object. So his reasoning is a little off. In the large and small paradox, Zeno says that groups of objects are both infinitely small and infinitely large. Therefore, they cannot exist. What does he mean? Well, let's say we have a box, and we divide that box into fourths, and we divide that fourths into fourths, and so on and so on. Zeno says that we can never stop dividing, as in order to stop dividing, we would have to get an object that has no size, and of course, that would never happen if we just kept dividing over and over again. Therefore, they are infinitely small. And he also says that if we took an object, say the box, and we cut it into fronts and backs, and then those fronts and backs and the fronts and backs, and we took the sum part of all those parts, we would get an infinite size. Therefore, he concludes that pluralities, or groups of objects, are both infinitely small and infinitely large. Well, there are some holes in his reasoning. For instance, he never establishes a reference frame. Let's say that we were looking at a city. We could say a city is a plurality of people, with people being the whole. Therefore, we could no longer divide the people into other things because they are not cities, right? But if we took a person as a plurality of cells, we could no longer divide the cells into anything because those are the whole. They are not people, with people being the plurality and cells being the wholes in that instance. Therefore, Zeno is incorrect when he keeps dividing pluralities into pluralities, as that would never happen. And therefore, pluralities are not infinitely small. So his reasoning is wrong. Why are Zeno's paradoxes important? Well, Zeno's paradoxes deal with a lot of important mathematical concepts. In fact, Zeno was one of the first philosophers to have attestable accounts of working with infinity. He also provides many alternative schools of thoughts to conventional ideas, such as motion doesn't exist or pluralities don't exist, which can be fun in their own right. In fact, many of his paradoxes still have things that mathematicians can't figure out. For example, if the runner can run an infinite amount of half marks, you can technically say the runner does an infinite amount of tasks, but how can they do an infinite number of tasks in a finite amount of time? It's questions like these why Zeno's paradoxes are still remembered today and will most likely be continued to be discussed in the future.